Okay. Assalamualaikum dear students. We are continuing our discussion on Fourier transform. We'll be solving some examples. So say, for example, here's an example. Find the value of an integral of minus infinity to plus infinity delta of t cos of 3t by 2 dt. And it says that if delta of t denotes the delta function. Okay, denotes the delta function. So let us first try to solve the integral. It is not the Fourier transform, but it is just a simple integral. If we'll solve the integral for this, we will be solving it like this. We know that integral minus infinity to plus infinity delta of at, it is a general integral, phi of t dt, it is equal to, let us first forget this one. A is not here, okay? It is delta of t. We know that then this integral, it is equal to phi of 0. This is equal to phi of 0. If we assume that our delta direct function is existing at t equal to 0. Okay, this we have discussed many times. Similarly, we have a general integral. If we have delta of at, सर आवाज साफ नहीं आ रही
आपकी आवाज बहुत कम आ रही है।
आवाज नहीं आ रही है
अब बहुत कम आ रही है। आप ठीक है?
Is it fine now?
यस सर।
Okay, so there is a general integration of minus infinity to plus infinity delta of at phi t dt. This general integral, it is equal to phi of 0 divided by a, phi of 0 divided by a. This is also a general integral for any a, okay, for any value of a less than 0. So this integral is true for that, okay? So therefore, our given integral can be solved in this fashion. So we have now our integration minus infinity, right? So therefore the given integral can be solved as below. Okay, so integral minus infinity to plus infinity, then we have delta of t, then we have cos of 3t by 2 dt. Okay, now see at t, if we assume that delta function is existing at t equal to 0, if we assume that delta function is existing at t equal to 0, okay, then we will have phi of 0, then we have phi of 0. Phi of 0 would mean we will have cos of 0, cos of 0, okay, cos of 0. So that will be equal to 1. So the answer to this integral is 1. That is the answer. That is how do we solve this integral. We have already seen in our previous lecture some special functions. We saw rectangular function. We also saw async function, rectangular function and async function. So suppose we have now a rectangular function. We want to calculate the Fourier transform of that function. We have a rectangular function and we want to calculate Fourier transform of the function.
अस्सलाम वालेकुम सर।
Walaikum salam.
तो सर ये था ना डेल्टा फंक्शन इनटू एनी फंक्शन लाइक ट्रिग्नोमेट्रिक
Yeah.
एक्सपोनेंशियल और एनीथिंग। आपने बोला था ना उसको हम डायरेक्टली लिखते हैं उसके इंटीग्रल को इक्वल टू 1। तो वो हम यहाँ पे डायरेक्टली लिख सकते हैं कि हमें ये पूरा
No, no,
प्रोसेस करना है?
no. What I said is, see, this is the general equation. This is general equation here. Okay.
जी
Integral minus infinity to plus infinity delta t into x of t or phi of t or x of t, कोई भी फंक्शन, ये तो हमने बहुत बार डिस्कस किया, इट इज इक्वल टू x of 0 और phi of 0. अब यहाँ phi of t जो है इस वाले में यू हैव cos of 3t by 2. फॉरगेट अबाउट डेल्टा t. अब इफ यू विल सब्स्टिट्यूट इट, अगर आप इन दो इक्वेशंस को कंपेयर करोगे, सो यू हैव टू राइट डाउन phi of 0. व्हाट इज phi of 0 हियर? इट इज cos of 0. phi of 0 is cos of 0. So at t you have to substitute t equal to 0. अब वहाँ था cos of 3t by 2, so it will be cos of 3 into 0, so it will be eventually cos of 0. That is why I said it will be equal to 1. तो वरना ये 1 नहीं है, वरना तो ये phi of 0 है इंटीग्रल जनरल फॉर्म में। आपको समझ में आया?
यस सर।
ठीक है, और तो नहीं कोई क्वेश्चन है?
नो सर।
Okay, okay, all right. Now see, I have a different function which is now a gate pulse or a rectangular pulse, which is like this. ये क्वेश्चन सबको समझ में आया? What about अरबा को ये समझ में आया? 70?
Yes, sir. Yes, sir.
Do you have any question in that? Whatever we
नहीं
discussed?
sir.
Okay.
ये सब मुझे
7,
समझ में
29, 29.
Yes, sir.
आपको बेटा सवाल तो नहीं है कोई?
No, sir.
Okay, all right. ठीक है, तो we have a different function now. It is a rectangular pulse. Say for example, its amplitude or its height is equal to unity, but it is existing from 0 to t, from 0 to t, and this is x of t. Okay, this is x of t. So we want to find out the Fourier transform of this rectangular pulse. First of all, if we would like to represent this rectangular pulse in terms of an expression, mathematical expression, we can write down expression. So the question is find Fourier transform. Fourier transform. Now see, mathematical expression for x of t will be like this. See, x of t, it is equal to 1. Okay, it is equal to 1 for, because it is 1 between time less than t and greater than 0. So between 0 and t, the rectangular function is existing. It is existent. And it is not existing anywhere else, and 0 otherwise. So it is not existing anywhere else. So x of t is only present between 0 and t. And what is the amplitude? It is equal to 1. It is equal to 1. It is equal to 1. Okay. And we know Fourier transform, general form of Fourier transform. Fourier transform or Fourier transform of any expression or any signal x of t can be written as f of x of t. This is the Fourier transform, which will be equal to x of j omega, x of j omega. Okay. And that can be written as minus infinity to plus infinity x of t, then e raised to power minus j t. Is that fine? Last students, मैंने कहीं गलती तो नहीं की है. निहाल, roll number 4. Is the expression correct? Roll number 4. Roll number 4. 7. शाहिद बशीर.
Yes, sir.
हाँ बेटा, मैंने ठीक लिखी एक्सप्रेशन, गलती तो नहीं की कहीं?
जी सर, ठीक है।
ठीक है. इफरा शबीर, रोल नंबर 10.
Yes, sir.
कोई गलती तो नहीं है बेटा?
Sir, e raised power minus j omega t.
बिल्कुल, e raised power j omega t है, minus j omega t. Then what is the second? What else I have to write down? Dt.
Yes, sir.
Dt. Yes. So this is the general form or general expression of my Fourier transform. Okay. Now see, we know according to our equation that we have, expression that we have formulated for x of t, we know that x of j omega, because the expression or our signal, it is existing between 0 and t only. Okay, it is existing between 0 and t only. So our limits will first of all be modified from 0 to t, not minus infinity to plus infinity. The second thing, what is x of t? My x of t is equal to 1. Okay, x of t is equal to 1 because its amplitude or its magnitude for this rectangular pulse, it is equal to 1. Then I have to write down e raised power minus j omega t. e raised to power minus j omega t dt. Okay, e raised to power minus j omega t dt. That will be the same. So we can write it down further. 0 to t e raised to power minus j omega t dt. Okay, e raised to power integration from 0 to t e raised to power minus j omega t dt. Okay, so I will ask students, what is integration of e raised to power minus j omega t? Hamad is here, roll number 12. Hamad, roll number 12.
Yes, sir.
What is integration of e raised to power minus j omega t? Hamad Anirabi, please turn on your mic. Do not turn it off. If you don't
Yes,
know,
sir.
you should say I don't know. Do not waste
Sir,
our time.
sir, I don't know.
Okay. What about Mudassir Ahmed Mir, roll number 11? Mudassir
Yes,
Ahmed
sir.
Mir. What
Yes,
is
sir.
beta? What is integration of e raised to power minus j omega t or e raised to power ax? आप अपनी माइक थोड़ा दूर रखो. What is integration of e raised to power ax or at?
सर असल में मैं नीचे गया था तो आधा छोटा हो जाए इसमें.
अच्छा.
यस
Sabrina,
सर.
roll number 15.
Yes, sir. E raised to
Roll.
power minus. Yes, sir.
Yes, बताइए. E raised to
Sir,
power
E raised minus j omega t divided by minus j omega.
divided by minus j omega. Very good. Then you have limits here, 0 and t. Okay. So we can then finally write it down. I will take 1 by minus j omega outside because limits will be assigned to only a term which has t associated with it. Okay. So then you have inside e raised to power minus j omega t, and then you have limits 0 and t. So we can further write it down 1 by minus j omega, 1 by minus j omega, then e raised to power minus j omega t, then uh, minus e raised to power 0. Okay, so that could be written as minus 1 by j omega into e raised to power minus j omega t, e raised to power 0 is equal to 1. Okay, uh, now I'll modify this x of j omega. So we are actually trying to find out x of j omega, that is the Fourier transform. So x of j omega could be written now. It could be written as minus 1 by j omega. That is one thing. Then you have e raised to power j omega t. E raised to power j omega t. Now see, e raised to power minus j omega t, e raised to power minus j omega t could be written as e raised to power minus j omega t divided by 2, okay, into or divide. I will write down divide e raised to power j omega t by 2. I am splitting omega t j omega t term into 2. ठीक है, तो ये मैंने दो में स्प्लिट की ये ऊपर वाली टर्म. We can write it this term in this fashion also. It is just like e raised to power minus x. फिर मैंने लिखा, it can be written as e raised to power minus x by 2 divided by e raised to power minus x by 2, because जब ये ऊपर आ जाएगा, ये वाली टर्म जब ऊपर आएगी, it will be e raised to power minus j omega t by 2. ठीक है, जब ये denominator, when it will come to the top in the numerator, then it will be like this. When bases are same, powers are added, it will come back to its original position. ठीक है, तो it is one and the same thing. So I'll write down here this thing. I'll modify this now. It can be written as e raised to power minus j omega t by 2 divided by e raised to power j omega t by 2. this step, if you are facing any kind of difficulty, I can repeat it. Is it fine? Roll number 70, is it fine?
Yes, sir. Yes, sir.
Okay, that is quite easy. Basit, is it fine? Basit,
Yes, sir.
समझ
Yes,
में
sir.
आया
Yes, sir.
बेटा? Okay,
Yes, sir.
so we are now obtaining a different form of equation. Now we can write down this equation as minus 1 by j omega into e raised to power minus j omega t by 2 is at the top. Okay, and you have e raised to power j omega t in the bottom, so it will be multiplied by 1. So it will be e raised to power j omega t by 2 divided by e raised to power j omega t by 2. J omega t by 2. So this is what we will be obtaining. Okay. Now we know from Euler's formula, we know that e raised to power I theta or j theta, e raised to power j theta minus e raised to power minus j theta, it is equal to twice cos theta. Sabrina, it is equal to twice cos theta, or it is
Yes,
equal to
sir.
cos theta?
No,
Cos
sir. It's equal to twice cos theta.
twice cos theta. Are you sure? Ikra Ayub 21. It is equal to twice cos theta.
No, sir.
Yes,
It
sir.
will be divided by.
It will be divided by twice cos theta.
No, sir. It is e raised
सर
to
जो
power
डिवाइडेड
j
में वो कॉस के साथ
होगा तो
मल्टीपल
वो
होता है ना
मल्टीप्लाई
सर?
हो जाएगा.
Okay, okay, okay. ठीक है, ठीक. What about Binish? Binish, what will be it?
सर सबरीना ने ठीक बोला. एक्चुअल जो है इक्वेशन वो डिवाइडेड बाय 2 आता है ना, तो आपने
हाँ, तो
नहीं
वो
लिखा वो, तो दैट विल बी मल्टीप्लाइड विद cos थीटा.
so it will be divided by 2. So you mean to say it will be equal to cos theta?
हाँ, अगर डिवाइडेड बाय 2 लिखेंगे तो.
Is it fine?
यस,
नो
सबरीना इज आल्सो राइट.
सर गलत है
गलत है? ये कौन कह रहा है गलत है?
सर रिजवान
Rizwan, Rizwan,
ये
what is the
साइन है
correct
सर.
equation now? Keep
माइनस
quiet.
टू
ये साइन है.
एक ही बोलेगा. What is the Rizwan
सर
will tell
साइन
me.
है.
Rizwan will tell me. Okay, please
सर
turn
टू
off
जे
your
साइन
mic. It is?
टू जे साइन थीटा
Yes, it is 2j sine theta.
यस सर
So it is 2j sine theta. 2j sine theta. Okay, ठीक है. So if we will substitute now this formula here, then we will have x of j omega will be equal to minus 1 by j omega, then you have 2j 2j sine of theta. What is theta here, Rizwan? What is theta?
सर थीटा इज ओमेगा टी बाय टू
Theta is omega t by 2. So theta is omega t by 2. Okay, what else I am missing? Denominator I am missing. So you have e raised to power j omega t by 2. Okay, you have j omega t by 2. Now see, you have a j in the numerator, you have j in the denominator. We have j in the numerator, we have j in the denominator. So this can be cancelled with this. I can write it down like so it will be equal to uh, just a second. It will be equal to you have in the numerator, in the denominator you have e raised power j omega t by 2. So it will be minus times, okay, e raised power minus times j omega t by 2. That is the one term. Okay, then you have 2 also. 2 is inside, वो बाहर आ जाएगा. Then you have in the denominator you have omega, then you have omega also. And just a second, just a second. Give me 1 minute. Okay. Can you hear me now? मेरी आवाज आ रही है बेटा? Am I audible to you?
Yes, sir. Yes, sir.
Okay. So I was here. Uh, okay, all right. So this is minus twice e raised to power minus j omega t by 2 divided by omega. Then you have inside, we will have sine of omega t by 2. Sine of omega t by 2. Okay, sine of omega t by 2. Now see, if we multiply this equation by t and divide it by t, so we will be having like this. We'll have minus 2 e raised to power minus j omega t by 2. What I have done, I have multiplied it by t, I have divided it by t. Then we have omega here. Okay, I have omega in the bottom. Then I will have sine of omega t by 2. This is the thing. Okay, I can write this in this form. This can be written as minus t times e raised to power minus j omega t by 2 divided by omega t divided by 2. Omega t divided by 2 into sine of omega t by 2. Okay, sine of omega t by 2. So I will further write it down here. Let me continue it. So we can write it down as it will be equal to minus t. I'm getting a minus sign. I don't know why I'm getting a minus sign. Let me check it later on. But t
सर
e raised
सर
for
इक्वेशन में हेलो सर
तो ये प्लस है।
सर इक्वेशन में ना ई रेज पावर जे थीटा हमने वहां पे माइनस कैंसिल हो जाएगा ऊपर
कहाँ पे?
जो आपने फॉर्मूला लगाई ना ई रेज पावर जे थीटा माइनस ई रेज पावर माइनस जे थीटा वहां पे माइनस कॉमन निकलेगा।
अच्छा हाँ बिल्कुल. We'll take a minus common in this equation. Very correct. I have
वो
not taken
पहली
the minus.
बार है सर।
Yes, I have not taken the minus common. So I'll change it here. You know it now. There was a minus common that was to be taken from this equation because it is e raised to power j theta minus e raised to power minus j theta. लेकिन मैंने जो सब्स्टिट्यूशन की है मैंने की है e raised to power minus j theta minus e raised to power j theta के बदले. So that is what I have forgotten. Anyway, but we were able to rectify it now. Okay, alhamdulillah. So we have t times e raised to power minus j omega t by 2. Then you have sine theta omega t by 2 divided by theta. Okay, that is omega t by 2, which we know it is a sinc function, sine c function. Okay, we know that it is a sine c function. So we can further write down then x of j omega could be further written as t times e raised to power minus j omega t by 2. That is one thing. And then instead of sine theta by theta, I'll write down sine c, sinc function of omega t by 2. So this is the final Fourier transform of a gate function. Final Fourier transform of a gate function. So we had a gate function here. Now, if we will try to plot it, since it is a sinc function, you know a sinc function, how it is plotted. I'll plot here. You will try to understand at your home. I'll then proceed ahead. ठीक है? तो अगर हम इसको प्लॉट करना चाहेंगे, इसका प्लॉट बराबर वही होगा जैसे sinc function का होता है. You remember a sinc function, it is a multiplication of two different functions. One is a decreasing function, another is oscillatory function, sine function and decreasing function, जो हमने sinc function में already पढ़ा है. So this is your x of j omega, x of j omega. Okay, x of j omega. This is not only x of j omega, this is basically x of j omega by t. अगर ये t जो multiply है इसको यहाँ लेंगे, it will be divided. तो the book has mentioned it x of j omega by t, the plot. Then you have 0 point here. Say for example you have 1 2 3. You have 2 pi by t एक point है, 4 pi by t. Then you have 6 pi by t. Similarly, you have minus 2 pi by t. Then you have minus 4 pi by t. And you have minus 6 pi by t. Then our graph will be something like this. It could be like this. ठीक है, ये वैसे ही जैसे एक this is amplitude spectrum basically. This is amplitude spectrum of a rectangular pulse. Amplitude spectrum of a rectangular pulse. It will be quite similar to that we already have discussed here. ये हमने already discuss किया था. Sampling function का plot कैसा होता है, ठीक है, हमने already देखा है that it is multiplication of oscillatory function and a decreasing function. तो बिल्कुल क्योंकि ये sync function ही है, वही यहाँ पे भी plot आया. That is quite similar to that. Now see, if I will have a same pulse, but it will be little bit modified. In my this example, the amplitude was equal to 1. The amplitude was equal to 1. I can modify now the question like this. Sometimes it can be asked, find the Fourier transform of the pulse. Find the Fourier transform of the pulse. You have x of t here. So instead of 1, the amplitude is 10. Instead of t, you have 2. So the pulse is existing between 0 and 2 with amplitude equal to 10. This is time here, time axis. This is x of t in volts. Okay. So the question could be find the Fourier transform of x of t, or obtain the Fourier transform. Find the Fourier transform of a rectangular pulse of duration 2 seconds. Okay, so time is in seconds. Time is in seconds. And amplitude may be in volts. So amplitude may be in volts. So find the Fourier transform of a rectangular pulse. वहाँ हो सकता है in your examination, the graph is not given, the plot is not given, the figure is not given, but only the question will be mentioned. You have to decode that and translate it into in the form of a figure. ठीक है, तो लिखा होगा find the Fourier transform of a rectangular pulse of duration 2 seconds and having a magnitude of 10 volts. Having a magnitude of 10 volts. So we can now draw the figure out of this question. It is very easy. And we also know that what is the Fourier transform equation. Fourier transform general equation is f of x of t will be equal to x of j omega, which will be equal to integration of minus infinity to plus infinity x of t e raised power minus j omega t dt. Okay, and according to figure we can now write down x of j omega, down x of j omega would be equal to integration of, I'll ask students what is the maybe Sana Jan 19, roll number 19, what will be the limits beta?
0 to 2.
0 to 2.
Yes.
Are you sure 0 to 2? Okay, it will be 0 to 2. ठीक है, तो 0 to 2 होगा. Then what is x of t?
10.
it will be 10. X of t will be equal to 10. Then it is e raised power minus j omega t, then dt. Okay, e raised power j omega t minus dt. And we can write it down then. 10 will come outside. You have 0 to 2, then e raised power minus j omega t dt. Then we can integrate it. So what is the integration of e raised power j omega t? It is e raised power minus j omega t divided by minus j omega. Then we have to apply limits between 0 and 2 also. Okay, so we can further write it down. Then it will be 10 divided by minus j omega, 10 divided by minus j omega. Then it will be e raised power minus j twice omega, then minus e raised power 0, which will be further equal to 10 times 10 by minus j omega, e raised power minus 2 omega, e raised power minus 2 omega, e raised power minus j2 omega minus 1. Okay, minus 1. And we can then write it down as can somebody help me? How can I write it down now? How can I break or split this e raised power j minus 2 omega? I'll ask students how can I split it. So maybe Binish will help me. Binish, roll number 24. आप बताओ बेटा कैसे करेंगे?
सर आएगा e raised power minus j omega
E raised power minus j omega
divided by
e
raised power minus j omega.
Minus or plus?
Plus, sorry.
Plus j omega. Yes, it is plus. Then it will be minus 1. Okay, I'll wait for the students. ठीक है, मैं इसको solve नहीं करूँगा. तो आप अपनी copies पे can you please solve it on at your own place and give me the final answer. What is the final answer? Wait for some time. I'll skip steps. Maybe Murtaza will tell me. Murtaza, what is the next step I should write down? Murtaza? Murtaza Rashid.
Yes, sir.
What is the next step I should write down now? Rianul Qadil, 36. What is the next step I should write down?
Sir, minus 10 divided by j omega. Okay, sir. E raised power minus j omega. Minus e raised power j omega. Divided by e raised power j omega.
E raised power j omega. Okay. The next step. What is the next step? आसिम आप बताओ. आसिम, उसके बाद क्या लिखूंगा मैं यहाँ पे तो सॉल्व है जी? क्या लिखना है मुझे अब? सैयद शमसुल आफाक, क्या नाम है? सैयद शमसुल.
यस सर.
हाँ, व्हाट इज द नेक्स्ट स्टेप आई शुड राइट डाउन?
सर इरेज बार j ओमेगा जो नीचे है इसको ऊपर.
अच्छा, उसको ऊपर लाएंगे तो क्या लिखेंगे बताओ?
इरेज बार माइनस j ओमेगा.
ओके, द नेक्स्ट टर्म. और फिर
सर फिर वो आएगा इरेज बार माइनस j ओमेगा माइनस इरेज बार j ओमेगा ब्रैकेट.
तो e raised power minus j omega, then minus e raised power j omega, and I can reflect negative sign. मैं common निकाल सकता हूँ. I can write it down as 10 divided by j omega, then e raised power minus j omega. अंदर रहेगा e raised power j omega minus e raised power minus j omega. Okay. Then we can substitute it. I can multiply here by 2 and I can divide it by 2 also. So multiplying and dividing by 2, we can write it down. It is 20 times e raised power minus j omega divided by omega into e raised power j omega minus e raised power minus j omega divided by 2j divided by 2j. What is the next step I should write down? Mumin, आप बताओ 45. What is the next step I should write down now?
जैसा
हाँ, क्या लिखना है इसके बाद मुझे? I have e raised power j omega minus e raised
सर
power.
लेकिन सर
हम्म
सर हमें था ना ऊपर ई रेज पावर माइनस जे ट्वाइस ओमेगा
ट्वाइस ओमेगा कहाँ था? ऊपर यहाँ?
सर ऊपर जी सर
हमने उसको स्प्लिट किया ना? We have splitted it.
ओके सर
That is what we have done. See, this is you have a confusion. See, try to understand this thing. If we have e raised power 2x, e raised power 2x, it is equal to e raised power x into e raised power x. Please turn off your mic. Turn off your Mumin, अपनी mic बंद करो. It is equal to e raised power x into e raised power x. इसी तरीके से if we have e raised power minus 2x, it can be written as e raised power minus x divided by or into e raised power minus x. When powers bases are same, powers can be added. Or we can write it down e raised power minus x. ये जो दूसरा term है e raised power minus x, you can say it is 1 divided by e raised power x. Okay, it is one and the same thing. Or we can write it down e raised power minus x divided by e raised power x. देखो, this same pattern we have followed here. The same pattern we have followed here. उज़मा, ठीक है ये?
जी सर
आप समझ में आया ये कैसे हुआ?
यस सर
Okay, ठीक है, तो let us forget this discussion. It is quite easy now. If you want to take a screenshot or if you want me to preserve this one, I'll write it down somewhere here.
नो सर इट्स ओके
कोई बात नहीं है, किसी बच्चे को हो सकता है इसमें confusion हो कि हुआ कैसा है, कैसे हुआ ये. I'll keep it here. Okay, so it will be present in the video also. All right. Now tell me what will be the term I should write down here. What is the next term? Sin. What is theta?
Omega.
Sine of omega. Very good. It is sine of omega. Now I want to transform it in terms of sinc function. Sinc function. What should I write down then? I want to transform this in terms of sinc function. What should be in the form of sine c or sinc function or sampling function?
साइन ओमेगा बाय ओमेगा
So what will be the first multiplier terms? पूरी term क्या बनेगी? 20
सर 20 e raised power minus j omega
बिल्कुल. और
sin c omega
sin omega by omega. ठीक है, तो ये बनेगा sin theta by theta. तो you had basically an omega in the denominator. You tried to shift it here. Okay, बाकी कुछ नहीं किया हमने. So the entire term
sin omega by 2 बनेगा सर.
sin omega by 2 बनेगा. क्यों बनेगा sin omega by 2? हाँ जी, बताइए. ये ठीक है. तो finally we can say x of j omega could be written as 20 times e raised to power minus j omega. Then it is sine c of omega. Sine c of omega. So this is the final Fourier transform of this function. ठीक है, ये पूरा इस ये जो थी ये rectangular pulse of different duration, इसका ये हुआ. ठीक है, आप इसको कर भी सकते हैं. You can plot it. There is no problem in that. You can still plot it. So that is one thing. इसमें कोई सवाल तो नहीं है? If somebody has any question, you can ask me. Do you have any question in that? Okay, if you do not have any question, I'll proceed to the next example now. So let me take another example. Abrar is here. Abrar है यहाँ पे?
Yes, sir.
Do you have at what time you have class after this slot?
It's at 2 p.m.
Okay, so I can take an example then if it takes few minutes extra. Another example is a signum function. Okay, Fourier transform of find the Abrar, is it okay if I will take few minutes extra?
Yes, sir. Yes, sir.
Fourier transform of signum function. Signum function. I'm taking those examples especially which are very much useful in your communication. So I'm trying to be very much selective in terms of examples in Fourier transform. Okay. So first of all, what is a signum function? So this could be the question. Find the Fourier transform of a signum function. Signum function. Signum function. Now see, a signum function may be represented, it may be represented by this representation SGN of t. It means signum function with a variable of t. Okay, mathematically a signum function is defined as follows. See, SGN of t would mean signum function with an independent with an independent variable of t. Okay, with an independent variable of t. So signum function, it is equal to -1 for t less than 0, then it is equal to +1 for t greater than 0. Okay.
So t greater than 0 पे -1.
T greater than 0 पे -1.
Yes, sir. Sure. Yeah.
सर
I
ये
don't
ठीक
I
सर ये
don't
ठीक
think so.
इक्विवेलेंट
No, no. This is correct. This is correct. I'll draw it here. ठीक है, this is correct. सिग्नम फंक्शन को जब हम करते हैं प्लॉट, दिस इज हाउ सिग्नम फंक्शन लुक्स लाइक. ये मैंने ऑलरेडी एक बार बताई थी क्लास में, उस वक्त आई हैव नॉट शोन इट करेक्टली. मैंने वही कहा था जो आप कह रहे हैं. तो दिस इज t, this is signum function of t. Okay, so for t greater than 0 it is +1. So for t greater than 0 it is equal to +1. For t less than 0 it is equal to -1. For t less than equal to 0 it is equal to -1. And do you know that signum function can be also written as combination of two step functions, u of t, okay, plus or minus u of minus t, u of minus t, u of minus t. A signum function can be written as combination of two step functions. Two step functions. What is this step function? U of t. U of t is this. This is u of t. Okay. What is u of minus t? U of minus t would be like this. This is u of minus t. Okay. And what is minus times u of minus t? That will be this function. Is it fine? ठीक है. रोल नंबर 24 आपको समझ में आ रही है?
Yes, sir.
54.
Yes, sir.
27. ये ठीक है बेटा?
Yes, sir.
Okay. So if we combine these two functions, अगर हम इन दोनों को ऐड करेंगे, इसको और इसको ऐड करेंगे, you will obtain a signum function. That is why I said that a signum function can be considered as combination of two-step functions, and especially unit step functions, because see, this is a unit step function. This is also a unit step function. This is a unit step function with -1 amplitude. Okay, so you have a -1 here. So minus ut means -1 times ut. So it means -1 times ut. तो जब इन दोनों को कंबाइन करेंगे we will obtain a signum function. Will obtain a signum function. Okay. Now we have to find the Fourier transform of this signum function. Fourier transform of this signum. Now Fourier transform of a signum function, it can be given as f of x of t. We know what is our x of t. X of t is our signum function. It is the general formula. Okay, this is general formula. Fourier transform of any function x of t is given by x of j omega, which is equal to integration from minus infinity to plus infinity x of t e raised power minus j omega t dt. Okay. Now our x of t here, it is signum function. It is sgn of t. So this is our signum function. Okay. So its Fourier transform will be also x of j omega, which will be equal to integration of minus infinity to plus infinity. Then you have sgn of t. Then you have e raised power minus j omega t, minus j omega t and dt. Okay. All right. Now we know that our signum function, it has two parts. One is from one is from minus infinity to 0. Another is from from 0 to plus infinity. ठीक है, तो हम इसको इस integral को we can break it down. Now see, we can further write it down. X of j omega, I'll write down according to, say for example, this is equation 1 here, signum function की equation. According to equation 1 and plot 1.1. So this is figure 1.1. Okay, figure 1.1. We can write down x of j omega. X of j omega can be splitted into two parts. One part is minus infinity to 0. So that means this portion. Okay, minus infinity to 0, because this side here, it is to minus infinity, and this side here it is towards plus infinity. Okay, so limits आएंगे minus infinity to 0. Then what is the amplitude of the signal? Roll number 42, Amir Yusuf, what is the amplitude of the signal here from minus infinity to 0? Amir Yusuf, 42.
Yes, sir.
What is the amplitude here?
Sir, 1.
1 ki minus 1?
Sir, minus 1, sorry.
Minus 1. It is minus 1. Okay. Then e raised to power minus j omega t. Then you have dt. The another part of the signum function is the positive side part, which will be from 0 to infinity, plus infinity. There you have 1. You do not have minus 1. You have plus 1 into e raised to power minus j omega t dt. Okay. J omega t dt. J omega t dt. All right. Now see, if we will try to find out x of j omega now, x of j omega has two parts. It has two parts. One is this one, minus infinity to plus infinity तक integration होगी किसकी, e raised to power minus j omega t dt. Then you have another part which is 0 to plus infinity, integration of e raised to power minus j omega t, then dt. Okay. And we can write down x of j omega will be equal to minus times, it is e raised to power minus j omega t divided by minus j omega. Then you have limits equal to minus infinity to 0. Similarly, you have integration here, e raised to power minus j omega t divided by minus j omega. Okay. Then you have limits 0 to infinity here. For this part, you have two parts, so integration will be done separately. So this is our x of j omega. Okay, x of j omega. Now if we apply limits to it, we can first of all take 1 by j omega common from the first term and from the second term also. Okay, then we will have something like this inside. e raised to power minus j omega t divided by j omega we have taken out. Okay, then we have limits, that is 0 and minus infinity. Okay, then we have minus e raised to power minus j omega t, then we have limits here infinity and 0. Okay. So this will take us to the next step. 1 by j omega will be, then x of j omega will be equal to 1 by j omega. Okay. Now see, in order to apply the limits in this equation, we have two terms. One is the first term and another is the second term. This term is when the time is less than 0, and this term is when the t is greater than 0. Okay. Please remember, we are actually taking Fourier transform of a signum function, and it is equal to -1 for t less than 0, and it is equal to 1 for t greater than 0. Okay, for t greater than 0. Now see here, in the first term, t will be equal to minus t. T will be equal to minus t. So we have here e raised to power minus j omega, then minus t. Then we have limits minus infinity to 0. Then we have the second term, which is e raised to power minus j omega t. T is positive, okay, plus t here. Then we have limits 0 to infinity. Okay, so upon simplifying it, we will have 1 by j omega. That will be the common term. Inside you have e raised to power j omega t. Limit will be 0 and minus infinity. Okay, then we have second term e raised to power minus j omega t. Then we have limit will be infinity plus infinity and 0. Okay, so therefore we will have 1 by j omega. Then applying limits to these terms, e raised to power 0 will be equal to 1. Okay, so it is e raised to power 0 minus e raised to power minus infinity. E raised to power minus infinity. Okay, then I have e raised to power minus infinity, e raised to power minus infinity minus e raised to power 0. Okay, so once I simplify it, we will have now e raised to power 0 is equal to 1 and e raised to power minus infinity is 0. Okay, then we have e raised to power minus infinity is 0 and e raised to power 0 is equal to 1. So the final answer will be 2 divided by j omega. Okay, it is basically like this. It will be like this, 1 by j omega. Then you have inside you have 1 plus 1, that will be equal to 2 divided by j omega. So x of j omega, it is equal to 2 divided by j omega. So please remember that if we have e raised to power t plus t, so this is t. So e raised to power plus t is increasing function. It goes exponentially, it increases exponentially. E raised to power minus t, e raised to power minus t, it is a decreasing function. It decreases exponentially, and when t will tend to be infinity, then e raised to power minus t, it will tend to 0. Here, when t will tend to infinity, then e raised to power t will tend to infinity also. Okay, so the final answer for the transform of a signum function, it is x of j omega, it is equal to 2 by j omega. We can have another example, which is like this, a triangular pulse. So it can be asked that find the Fourier transform of this pulse. X of t, this is 0, this is p1, 0.2, p2, this is 0.3. So you have time axis here, and then you have amplitude equal to a. Okay, amplitude equal to a. So this is a triangular pulse. Triangular pulse. So it asks that find the Fourier transform of triangular pulse given in the figure. Now see, if you will try to understand, uh, in this figure, you have basically two lines. These are both straight lines. One is going from P1 to P2. Another is going from P2 to P3, and that makes the shape. Okay, that makes the shape. So we can assume that these two, this triangular pulse, it is basically made up of two straight lines. It is basically made up of two straight lines. One line is from P1 to P2, another is from P2 to P3. Another is from P2 to P3. अब देखिए, the equation